Hello, everyone, and welcome to a CircuitPython conversation with Kattni and Jeff. We decided to get together to do a stream for CircuitPython Day and talk about some recent projects that we worked on. We thought it would be best to have someone to chat with, and so we decided to do sort of a basic interview of one of us, and then we swap it up and go with the other one. I'm Kattni. I am sponsored by Adafruit to work on CircuitPython. I primarily work with the libraries and write guides and a lot of other miscellaneous things. But in terms of the CircuitPython project, I'm sort of the overseer of all the libraries. And sometimes I get a chance to actually write them, which is what my project is going to be about, is the LED animation library. And with that, I'll turn it over to Jeff to introduce himself.
Hi, as Kattni said, I'm Jeff. I've been working with Adafruit on CircuitPython for around a year now, although I've been working with Python for more years than I'd care to admit. I work primarily on the core, but sometimes, like Kattni says, I also get a chance to do projects, although today I am going to focus on a particular couple of pieces of work I did to the CircuitPython core to enhance the projects that you can do with CircuitPython.
All right, excellent. So in terms of the format, it's going to be sort of an interview conversation type thing. I will start with interviewing Jeff. And then I'll ask a series of questions. We'll have a couple live demos. And then if hopefully we have a little time to answer questions. If you want to be able to ask questions, please join the Adafruit Discord at adafru.it/discord and go to the live broadcast chat channel. And any questions that get posted there, we'll try to answer during the stream. Then we'll switch. Conversation will be with me, and I will do some live demos, and I will hopefully have some time to answer some questions if anybody has any at the end as well.
And we do have to keep it to the hour because the next stream will be Scott doing his weekly deep dive.
Yep. So we'll be finishing up promptly at or slightly before 5 p.m. Eastern. Had to think about it. So this is CircuitPython Day. We chose today because it's a fun, snaky number. And also, it's a little bit later than last year. Obviously, there's been a lot going on in the world, and this sort of gave us a little more time to plan. So we went with September instead of August this year. And in terms of CircuitPython Day, we have dedicated today to Lambeau Labs Makerspace. On August 4th, Beirut, Lebanon experienced a massive explosion that left many dead, injured, as well as leaving thousands homeless. In the aftermath, Lambeau Labs Makerspace stepped up and joined the many efforts to rebuild their community, including search and rescue, restoring damaged homes, and volunteering in many ways, including providing aid tents to help the community find food and shelter, and joining construction engineers to help with the rebuilding process. Last year, Lambeau Labs was a partner for CircuitPython Day, and this year we've dedicated CircuitPython Day to them for all the amazing work they're doing in the Beirut community. If you'd like to help with these efforts, there are two fundraising links that you can go to and donate money. The first one is the Impact Lebanon fundraiser. The link is adafru.it/impactlebanon. And the second is ANERA and Global Shapers fundraiser. And the link to that is adafru.it/globalshapersbeirut. Both of these are groups that are doing positive work in Beirut to help with the aftermath of the explosion. And details about each fundraiser can be found at those links. So with that, I guess we'll get started. So Jeff, why don't you talk a little bit for a moment about what project it is you're going to be talking about?
Yeah, so when it comes to CircuitPython, you have a certain limited amount of storage within the device itself. And like you do maybe with the digital camera, or like we did with our phones years ago, you can add to the storage by putting in an SD card. And so what I'm going to talk about is how did that evolve over time, and in particular with two projects that I did within the last year to enhance it.
All right, great. So how did SD support begin with CircuitPython?
Actually, that traces all the way back into MicroPython. So Damien George and other MicroPython contributors wrote an SD card library. And then early on, Scott adapted that into CircuitPython under the name Adafruit SD card. And of course, there are other contributors on the CircuitPython side as well. But between those two libraries, basically, any microcontroller board with CircuitPython is going to be able to work with an SD card.
Great. What prompted the decision to update it?
So we had identified a couple of problems with the way it worked. And so, for instance, there was a bug that would manifest if you were showing a non-disk bitmap from your SD card that would update in the background, but then you also wanted to like read or open a different file on the SD card at the same time. So the situation might arise that CircuitPython would just lock up. And this was kind of due to a decision that we made in how CircuitPython differs from MicroPython. So in MicroPython, you can actually write in your code during this stretch of lines of Python, interrupts are not permitted to occur. And that would stop any other processing from taking away from what you were doing. And while you're reading from an SD card, you need to do that. But that meant when you bring that over into CircuitPython, we didn't have that protection. You can't write that in CircuitPython because we'd like it to be easy so that nobody has to think about these things. But that meant that to have a bulletproof kind of implementation, we had to bring it from being a Python program or Python code into core code. And so that's why we came up with the idea of creating what is now called SD card IO. And then we also added a second one that is called SDIO IO.
All right. So what's the difference between SD card IO and SDIO IO?
I set you up for that one, didn't I?
You did.
So basically, there are two primary electrical interfaces or command interfaces to SD cards. And the one that is a lot easier for microcontrollers to work with is the one called the one that we call SD card IO or Adafruit SD card, and it works on the SPI bus. And that is 3 or 4 wires that are connected between the controlling microcontroller and the board, one to transmit data from the controller to the SD card, one to transmit it the other way, and then a clock signal and a select signal that kind of keep everything happening at the same moment. And that's well supported. It's supported on Arduino. It's supported on anything that you would care to do microcontrollers with. But then we have a few boards that support another system of interface called SDIO. And with SDIO, you can transmit up to 4 bits at a time by using additional connections between the microcontroller and the SD card. So your more capable microcontrollers like the STM32F405 and then some of the Atmel SAMD chips have support for this. It's usually on the devices that are bigger and have more pins. You can hook those up and you can get a speed increase.
Wow. All right. So let's talk about the gains in performance then, since that was obviously the goal.
Right. Yeah. So I guess at this point, do we go ahead and bring up my demo? Basically, each one of those increments kind of gets you going faster. So here, what I've got is this is a Adafruit board in a little 3D printed enclosure. Thanks, I think, to Noé and Pedro for that. And it has a Feather NRF, whichever the number is, I'm blanking, and an SD card and the TFT display sitting on top of it. And it is reading the bitmaps from the SD card and displaying them on the display. And as you can see, it kind of takes its time. And so this is using the original Adafruit SD card implementation. And so when we go over to the new the new SD card IO implementation, it just kind of gets things done faster. So the long pause between the refreshes is not what you're looking at, but you're looking at the speed that each one of them kind of comes down the screen as it is actively refreshing. So, this one is maybe 2.5 times faster. Mm-hmm. And so that means if you have an application that has a background and you want to change that background, it's just going to work a little bit better. So these are like 16-bit BMP files. They're not compressed. And each time it displays, CircuitPython has to read it from start to finish off of the SD card.
Mm-hmm.
And of course, when you're working with display I/O, you're going to want to try and find other ways to reduce the amount of display updates. And that's its whole own thing. But then the star of the show, are you ready for the star?
I am.
I am. You am. These are both the NRF 52840 feathers. This is the STM32F405 feather, and it is using the SDIO I/O. And once again, you get a really big bump in how responsive it is at reading the bitmaps. So these are all the same files, and they're just 3 SD cards off of kind of the junk pile. And we've got a clear winner in terms of, how fast do you read files? So that, basically is what I wanted to show in the demo. And having done that, I will pop one of these open and just show you what's inside. I love their snap fit design cases. You've got to pop the SD card out before you open it up. That's the trick. So yeah, printed these off on my 3D printer. And then I chose to drill out where the holes are for the screws. You can, I think that they're intended to maybe accommodate the screw and kind of form a thread, but with the nylon screws, that just doesn't work. So I drilled them through and put the nuts on the back and the screws on the front. And this is super easy to set up. You just put the feather in. You'll want to get the short male headers if you do this, just so that it fits within the size of the enclosure. But it's real easy to put together. And then you've added the SD card, and you've added the display, which actually includes this touch screen, to your project. And the libraries are right there to make all of those elements of CircuitPython work for you. So that is what is inside those. But what is inside here is going to be a little different. So I mentioned that the SDIO connection is a little bit different. So the first thing is that there's not an SD card inserted here, because the STM feather has the SD card slot right on the device. Yeah. And so this has the extra connections that are necessary to let you use SDIO I/O.
Right.
So it would be slightly frustrating if you were going to do this permanently but wanted to swap out the SD card. You'd need to modify this case so that it had not this SD card slot, but so that it had an SD card slot about right here, or right here, I guess. So if you want this set up, there's maybe a little work before you can turn it into the digital picture frame of your dreams, because you'll need a way to switch out the card. But so those are the kind of basic levels of hardware that I've been using the SD cards with.
Very cool. So what new things does this allow us to do?
So mostly it allows us to do things that we already did more quickly. I mentioned these problems with accessing the SD card both from your Python code explicitly, while at the same time you were doing it automatically. And that could include if you are playing an MP3 file, or if you are showing a display I/O bitmap. So when you use these new interfaces, the problems where you would get lockups, they just go away, because the access to the SD card is correctly managed when you're doing it in your code. Then display I/O will wait to update the screen. So some of the projects that I've done with SD cards, I did a little MP3 player app, which there's a guide about, and I hope that's ready to go on this. Let's see. No, that's not the demo that's ready to go. But you can play MP3s. This is playing MP3s from the SD card, and the speaker is not hooked up. But yeah, the idea of this demo is, you press the button and it plays the other MP3 file. So audio files are a great thing to do, because you can put, hundreds of hours of MP3 audio on your SD card. And
And the flash that normally comes with the board is significantly limited. You would not be able to do that at all.
Mm-hmm. Yeah, it depends on the particular board that you have, but they range anywhere, usually in the megabyte, single-digit megabyte range.
Yeah.
Which you can have a good amount of MP3 audio on there already, but once you take the MP3 audio capability and add that to the SD card capability, it's like you have as much as you want. So do you want spooky sounds for your Halloween display? You're going to want an SD card and, go to websites for free sounds and get the hooting owl and get the, creaking skeleton and just put them all on there and have it play at random intervals would be a great fun project to do.
Yeah.
Other than that, I don't necessarily have a lot of ideas that use SD cards. Oh, I do want to talk about one other thing. So if you want to do data logging, say you've got a little sensor, a battery, and a SD card, you can log from that sensor onto the SD card. And I don't have a demo of that right here, but with the older versions of the libraries, you could maybe do a couple of logs per second. And with the new version, you can actually do hundreds of logs per second.
Wow.
Now, this depends on how much, this depends on whether you're willing to tolerate the loss of the last bit of data when your battery runs out.
Yeah.
But yeah, you can actually log a lot more with the newer drivers than with the old drivers. So and I should say at the outset that these are new things that are available in CircuitPython 6 alpha versions. I think that they were not in version 5.3. So you're going to get out there a little bit in front of everybody else and get the 6.0 alpha if you want to try out these features.
Yeah, and for sure, it's actually been pretty stable. When there's been major fixes needed, we've quickly gotten on them and fixed them. But we're moving quickly towards a beta.
Right.
So definitely try that out, and to get A, access to the new features, and B, we just love it when you try out our betas and let us know what's wrong.
Yeah, we depend on the community to let us know where to work. And a big part of that is trying your project. And if you hit a snag, we want to help you work that out, because if version 6 is not as good as version 5, we've got problems and we need to work on that. But at the same time, with any complicated project, none of us is testing all of it, and we're not going to catch your specific case because everybody's doing stuff that's a little different.
For sure. So let's say somebody wanted to get something, they don't have any hardware yet, but they wanted to try this stuff out. What would you recommend as sort of some starter hardware?
Right. So, these boards that I've been talking about already, they are pretty good, but you're going to have to do a little soldering because this does not come with the headers installed. So if you think that this much soldering sounds like fun, then combining a feather wing and a feather is a great way to do it. And there is a pretty big range of boards. If you don't feel like soldering, if you just want something that is all in one, this is called the Pi Portal. It's been out for a pretty long time. Another 3D printed case from Adafruit that I've embellished with this little front panel. I don't have a demo running on it right now, but it has, again, a somewhat larger screen. I think that's a hair larger. Yep. And it has the SD card slot right there. This one has built-in Wi-Fi, so you can do online projects. So a project that I have wanted to do, I've been really tempted to do, is imagine that this device sits on your desk or at another spot, and it goes out and it looks at your podcast feed. And overnight, it downloads your favorite podcast to the SD card. And then in the morning, you touch the touch screen and it starts playing, because there is a speaker. There's a speaker connector on this, right? Let me open up item number 2 or number 3, depending how you count. This is, so the Pi Portal comes in 3 sizes. This is the original size. There's the Pint, which I don't have, and there's the Titano, which is a slightly bigger screen again. And I see Anne is dropping the links to these items in the chat, so thank you for that, Anne. Yeah, so this has got a connector for a standard speaker.
Okay.
And so, yeah, back to my little story of the project I would enjoy doing. It's going to download your podcast at night, store it on the SD card, and then when you're ready, you just play it. And so, you'd embellish that maybe with a little logo of your podcast or whatever. But the key would be it becomes kind of a low bar of how hard do you have to work to get that podcast or, whatever it is. But yeah, this would download it for you, play it, and it just, becomes an appliance that makes your life a little better.
Excellent.
Other items. This isn't so much what I would suggest to anybody else, but I just want to show it. When it came to developing the SD IO, we're actually supporting that on both the SAMD 51 microcontroller in the Metro Grand Central. In the Grand Central M4 Express, I think it's called. But I didn't have that board, and it doesn't have the socket directly on it. So I picked up this board from Microchip, and it has the SD card connected by SDIO. And so it's called the Microchip SAM E54 Explained. And it was a fun little detour to add that because I had hardware that had presumably been wired correctly rather than some attempts at wiring my own SD cards with SDIO. But that doesn't have to be a problem for you because Adafruit has since then put out a card with the correct pull-up resistors and all that. Anyway, so that was a little detour. The last piece of hardware I wanted to suggest is one that I showed already. This is the Pi Gamer. Again, it has the speaker, it has batteries, it has these fun controls. And so like I mentioned, there's a project out there to turn this into an MP3 player. So, you could stick this in your pocket, go out for your jog, listen through the headphone jack. There's a headphone jack as an alternative to the speaker. Or just whatever else you imagine. Do you want atmospheric background MP3 music in your next game that you're creating with CircuitPython? This would let you do that through the SD card and through the MP3 playback. And I think those were kind of the top boards. But any board or almost any feather, you can also put a board called the Ada Logger Featherwing, which has an SD card, and I think it has the real-time clock, which for data logging is great for knowing what time it was. The temperature went above 25 degrees, but when was that?
Yeah.
So yeah, those are some of the alternatives that you have for hardware, kind of ranging from no solder up to I'd like to design my own product or level. But yeah, that's what I got.
Great. So we have time for a few questions. One question was from Scott, who said, "Are you hitting the limit of updating the display?"
So am I hitting the limit of updating the display? When I was writing the sample code, I did see some things that I don't quite understand about changing the bitmap versus updating the display, and I kind of worked around them to the best of my ability, but I'm not the person who's most knowledgeable about display I/O. And I think that there was a pull request recently that we're adding so that you'll be able to have a lot more direct control over when does the screen update by calling the refresh function. So if you have more information to add to that, I would be happy to hear it. But I'm pretty sure that the way that this code is written, display I/O is reading, is undertaking the activity of refreshing the screen as efficiently as it knows how. But it's possible that I overlooked something, and I'd be happy to share the code if somebody wants to look at me kind of in detail. I see over on the chat, Foamy Guy says SD card is great for saving game state on the Pi Gamer as well. And that is definitely true. So basically, when CircuitPython operates normally, your CircuitPy drive is not writable from your CircuitPython program because that's reserved for the host computer to update the code.py. But the SD card is always writable by CircuitPython. So yeah, if you're writing a game that's going to save when you go from level to level, or whatever other mechanism you have, then absolutely. And you could store just more graphics. You could load your level graphics off of the SD card, and all sorts of things, just expanding kind of the scope of a game you could create.
That's excellent. Any other questions? If you have any questions, please post them to the live broadcast chat on the Adafruit Discord.
Mm-hmm.
We have a couple more minutes if anybody has any further questions.
I see someone shared one of their PyPortal projects. It says, I have this querying my Last.fm profile for what music I'm listening to currently, and the PyPortal shows me the album art too. That is super cool. What else have I missed? No. And Noah's going to add the STM feather to the list of his boards to 3Dify. Anyway, I think that's it for questions.
I think so too.
All right. Are you ready to turn this around and answer a few questions for me?
I am.
All right. Well, what is it that you wanted to tell us about today?
So I was involved in writing a library called LED Animation that started off very small and has since become very involved. But it's to make displaying animations on LEDs simpler. To actually do that is a lot of code. And we wanted to make it so that you could, with just a few lines of code, run a fancy animation. So we wrote a library for it, and that's what we're going to talk about.
All right. Was there a particular inspiration behind the library?
So the library itself was created at PyCon 2018. But all that was added during that sprint were color variables. So, the tuple, the RGB tuple, and set a variable for it. So red would be 25500, and so on. And the idea was, at the time, was really to do what we ended up doing with it, but it didn't come to fruition for quite a while. And so for the longest time, it was just color variables and really wasn't used.
Mm-hmm. Well, still, I mean, colors are a big thing, because I've tried to introduce people who aren't into programming on the LEDs. And I ask them, well, do you know like HTML colors or CSS? And when they say no, it's like, oh, I don't know how I'm going to talk to you about colors, because, I'm familiar with them for a long time, but I don't know how to teach people. But when you can say amber,
yeah,
people know what that means, right?
And for the longest time, actually, we were copying and pasting that entire file into other libraries.
I've seen that on Learn.
Yeah, because since the library was very underused, and that's all there was to it, didn't want to add another import to code. So the Clue library, for example, has color variables built into it. And that's all stuff that could change now, but it's how we did a lot of things. So adding animations didn't happen until the holiday season in 2019, when we decided to add NeoPixel strips to our Christmas tree. And we started designing more and more animations and different ways to map them out so that animations would actually like wrap around the tree. And that means like you're mapping out different length strips because it's conical. And as we designed more animations, we wanted to share them with others to use. So the inspiration was essentially real life uses that basically shaped how the library was written, and what was added to it was inspired from what a project we were doing and wanting to be able to share that, feature concept with other folks.
And DV says NeoPixels make everything better, which I think is pretty much true.
I agree.
So what when you think of animation, that's fine. But if what if you want to do something else at the same time?
So this library was entirely designed to be a non-blocking library. It was designed so you could easily have multiple animations running at the same time on maybe multiple strips. And all of the animations are clock-based, so you can do other stuff super easily. The idea was to ensure that you could create projects like, for example, Aaron St. Blaine recently created a project that is a light-up ukulele, and it does different things.
I helped her with the code on that.
You did. So it does different things when, like, does different animations when you do different things. So it's waiting constantly for a large series of inputs, you know, strumming a single note, moving the ukulele around, things like that. And all of this was able to be done with the LED animation library. So that's one example. There are many using this library at this point, and many of them involve buttons or inputs or sensors or all sorts of things that create different levels of interactivity. And the library was designed to stay out of the way, essentially.
Mm-hmm. And so something that a lot of people say is, well, CircuitPython is slow and other environments are fast. And, well, we don't need to make any, claims of CircuitPython being the fastest, but this library is fast enough, right?
So it absolutely is. You can't really discuss the speed and performance of the library without also bringing up PixelBuff, which is it's something that's built into the CircuitPython core that moves the pixel math. This is a very, very high level explanation of PixelBuff, but it moves the pixel math into the C code, which is significantly faster than it being in the Python code. And so we made that work with NeoPixel and DotStar and so on. So all of them use this chunk of performance stuff that was added to the core to be significantly faster. And we, it just sort of bled into how quickly the animation started running. And really this whole thing started in 2018 at PyCon when I was complaining that rainbows were too slow. Mm-hmm. I wanted faster rainbows, and that triggered PixelBuff. And in the end, this library really ended up being a test suite for PixelBuff. Typically, we began with what we wanted to do. For example, I wanted a sparkles animation. So we hacked together sparkles and we made it work, and then went back through it to optimize it to work in the best way possible, and to use the least amount of memory and the highest possible speed that we could do it. And then we put that in the library, which pulls it out of your code.py. So there's 2 lines of code now to run that sparkle animation, and it's much faster than ever possibly could have been before PixelBuff was added. So it's in tandem with another feature that was added to CircuitPython, but it is definitely fast enough.
And I assume that kind of that speed depends on which particular microcontroller you're choosing. Does it also depend on the type of LED?
So it doesn't depend on the type of LED. In terms of the type of microcontroller you're using, if you're using one of the super basic ones, so some of what is used is something called a function, or I don't remember exactly what style of thing it is, but time dot in Python. And then it's monotonic _ns. And time.monotonic works on all boards, but the nanosecond version of it doesn't. And we found this on the Christmas tree is if you leave it running for a very long period of time, it slows way down because time.monotonic loses resolution the higher it goes, because it's just based on how long the board has been on since the last hard reset or power cycle. So we added the _ns to the boards that have it, but those that don't, we had to add extra code to make it not slow down over time, because the Christmas tree would do it, and it took us a while to figure out things would end up out of sync. I think there's code in there now, if I remember correctly, that just does some extra math to keep the resolution better so that on a trinket, for example, it doesn't slow down. But the speed for the most part is pretty much the same across all of the things. The amount of stuff you can do at once is limited based on the what type of board you're using. But it's not an issue of like how fast the animation itself will go. You know, if you run one animation on a very tiny board, it's going to still be the same speed as if you were running it on another, as long as you are updated far enough to have pixel buff.
So it's more a matter of the maximum complexity
yes.
of what your program can be, which I think is just kind of inevitable. The board was designed with less capacity.
Yes, it was.
So,
and there are, yes, somebody said in the chat, limited like a RAM issue. That's exactly what's going on. The M0 boards can run almost all the animations alone, so individually, and then some of the basic animations you can run together. But there's at least, I want to say, one or two animations that are just too complex for the M0 board, period. And a few of the examples we put together with the more complicated animations, we specifically said in a doc string at the top, this probably won't work on an M0, so use an M4 or better.
Right. So I'm just going to interrupt for a second. Don K has a correction to what I said earlier. The Adafruit Feather M0 has an SD card but does not have a real-time clock. The Ada Logger Featherwing does have an SD card and a real-time clock. So I was confusing two different products.
Gotcha.
So thanks, Don. So I think now is the time when you were going to show us a demo.
I was.
Did you have any of these LEDs, around you or nearby?
I don't. There are no LEDs anywhere.
Oh no, Kattni.
So the last thing I wanted to say is there's very little limitation on the number of LEDs or the form factor, even on smaller boards. That's more of a power issue, not a matter of can your board communicate with that many LEDs. There's very huge numbers that can actually be communicated with. So, live demo.
Yeah.
First up, I'm going to bring up my hover cam here. That is, of course, slightly out of focus. And I don't know what happened, so I'm just going to leave it. Because if I mess with it, I'm going to screw it up. So these are two NeoPixel feather wings that are running on feathers. One of them's an M4 and one of them's a NRF52840. That's irrelevant. It's what I had soldered properly. And this is running almost all the basic animations, just in sequence. I wrote a guide about this. There is a guide about this library. And I grabbed like all the basic code from the guide quickly and just mushed it all together. And this is what I used for the guide. There's 3D printed diffusers on top. That's why they're sort of diffused and why it doesn't look like a NeoPixel feather wing. But this was all the stuff that we wanted to be able to do. And it just, like I said, started as code.py that got very, very complicated. And we just kept grabbing chunks out of it and putting it into the library. And eventually we split the library up so that every single animation is its own file. And that was what made it where the M0 can work with most of it. When they were all in one, it failed on import. It was too big. So the amazing thing I did, which I didn't, it's featured in the guide, but I did not actually do it for the guide, is my LED wall. Again, see, the display is backwards. And so if I'm looking at the screen, I always point at the wrong thing. So this is 13 20 NeoPixel long dots strips. They have flexi wires. They're designed more for They're designed more for wearables, kind of. However, they worked really well on the Christmas tree. All of this, I can point, all of this was on the tree. And after we took down the tree, I was like, I need something back because the tree was so amazing. So it's entirely cable clips, 3M command cable clips. After I took a level and measured out where to put them, and then secured it all onto the wall. And these are the 4-inch pitch. There are 4-inch and 2-inch pitch. The 2-inch pitch are shorter because it's still 20 LEDs on a strip. And it turns out these worked really well for the LED wall. There are so many NeoPixel strip form factors. The dots are kind of expensive. So if you're looking to do your own grid and you want to be able to do it at a little less cost, consider just getting a low density NeoPixel strip, or a series of those rather, and then hook them up. There's plugs on the ends of every one of these, so I was able to just plug it in. So the actual thing zigzags. So if I were to put a single comet, for example, where it just kind of goes across without any of the fancy grid mapping stuff that got put into the pixel library or the LED animation library, it would just go back and forth. And so what we did was we added helpers to the LED animation library that make it super easy to take your grid of some sort. Well, like the feather wing is a grid. And it's a grid that goes across this way. And so you can tell it's one of the options is to tell it that it's alternating. And you tell it that it's horizontal. So you have like a few things you tell it, and you tell it the number of LEDs total, and then how long the side is and how long the bottom is. And then it just makes the grid for you. And so that is what allows animations like these, where they're treating it like it's a grid and they're moving across the grid instead of having it go in a weird sequence, because the LEDs are soldered in serial
in a particular order.
Yeah, and it treats it like a strip. CircuitPython does. So it sees that grid and treats it like one strip. And really, this is one strip. And so, but we wanted it to act like a grid, so we can display all kinds of stuff on it. And so that's why those helpers were added. They're pixel mapping helpers, and there's a few different ones in there depending on how complicated your grid setup is, or what it is you're trying to do with it, for example. And there's also the option to individually label every single pixel and create a pixel map yourself, which is super tedious. But
again, Aaron did it in the ukulele project.
And the reason that we put that in there is because trying to identify a pixel map of a conical tree was not going to happen without individual things. And we actually had a star on top of the tree that it went up and then out, which was actually a single strip that did this. According to CircuitPython, it was actually individual bits. And we wanted it to be able to go up and go out like a star. So we pixel mapped that very carefully as well. And so all of this came out of like, basically we were like, we want to do this thing. How do we do it? Let's make it easier. And that's sort of how it evolved. There's all kinds of animations. The basic animations are like blink and color cycle and pulse and the basic comet. And then there's a few rainbow animations, which are sort of rainbow versions of those animations. There's sparkle. There's a rainbow version of that. I feel like there's more that I'm missing.
Well, head to the Learn Guide if you want to see them all.
Yeah, that's exactly. And it makes things super easy. Basically when we designed it, there was one project that was the first project that used it. And it was a project by Noah and Pedro, I believe, that it was the first time it was used, and it was a mirror reflective box type thing, like an infinity
Oh, the
cube.
infinity cube.
Yeah.
I have the 3D print, and it's been waiting to be assembled for a very long time, but
So
that was super cool.
Yeah, it uses the library, and they were like, this is so simple. they just wrote 6 lines of code, and it looked amazing. So they started using it, JP started using it, Aaron St. Blaine started using it, and it blew up from there. And I mean, JP has said to me multiple times he'll never go back. He will use this library forever for everything he possibly can. And so it's been great to see it used. That's another thing. You write a library or a guide, and you don't know if people are using it, except when maybe you get feedback about something being broken.
Right.
So you have no idea. But now I'm just seeing all these projects where people are using this library, and it's been super cool. And like I'm able to help folks out. Right now, one of the guys from DigiKey designed a huge clue, and he's got 4 NeoPixel grids on for the display, and each one goes like this, and then there's 4 of them this way. So he had to be able to map a strip that basically did this. And it took some effort, but we figured it out. And it was like a small helper that we put in code.py that generated the grid out of these multiple angles of things that were involved, and got it so that he can run animations on that as well. And he wants to be able to put images on it, which we've done with the LED wall, but it's been super hacky code, like real big, and memory hogging, and usually it results in memory allocation failures unless we disable all the other animations. But it's looked really good.
I'm guessing that once you look into it, you'll find a better way, and you'll be able to store some reasonable images instead of being limited.
Yeah, I think so. And I think that also comes with some of the work that you guys have been doing on the core, with possibly getting Display IO to work on, matrices or whatever. We may be able to make images.
Yeah, there's a different kind of LED matrix that CircuitPython Display IO does work with now, but those are different than these a little bit.
Right, because it's a matrix. It's not.
Yeah, it is really a matrix.
It's not a grid. All right, it's not something we created out of a strip. Yeah, it's not a line. Exactly. So yeah, I love it. Obviously, I have it on my wall. And that's running on a Feather NRF 52840. The sort of plan, because the Christmas tree was running on one as well, and we could control it via Bluetooth, is to be able to control that via Bluetooth. For the most part, we actually, because we got tired of pulling a Feather off the wall and walking it over here and then making an iteration and then having to go back and plug it in to see if it worked, there is 9 feet of USB cable on that Feather. So it's way behind me, but I have it plugged into my machine. And if you want to see a quick, let me see if I can share a different app.
Sure. While you're doing that, AP Killer says, what is the SPI chip you talk to? And so we work with 2 kinds of LEDs primarily for the LED strips, and they're just known by the names NeoPixel and Dot Star. And there's not a separate SPI chip. The signaling comes from the microcontroller and goes to the first LED, and then the first LED sends the signal onto the second LED, and so forth. So I think there may be a more technical answer than that, but they're called NeoPixel and Dot Star, and they're kind of their own thing. NeoPixel definitely is its own thing.
So we're currently iterating on new ideas on the wall. So this code is super complicated, and I'm not going to explain it. This is just to give you a quick view of what building the library looked like. There's a lot going on. There's, a bunch of commented out code, bunch more going on. And the loop we finally get to is also still very complicated. So the imports are still super beefy. But that turned into this, where I set up my pixels right here. This is the mapping to make the NeoPixel Featherwing work this way and this way. These are the animations. These are the animations that use the mapping. Then you list all the animations that you want to play, and that's what your well-true loop looks like. And
so if I had a sensor or something, that would kind of alternate with the code to animate.
Yeah, exactly. Or you would tell it if the sensor results are higher than foo, animate this thing, or something like that. Because you can also animate individual animations. This is using animation sequence to play all of them at once. But that's what gets to this.
Right.
And this is just a series of the basic animations running. But right now, because we're still iterating on everything, the code for the wall is very complicated. But I guess the reason I wanted to show that is that's how things started. And like, we got it to an API that is very simple.
Yeah, people were saying about Dan's broadcast earlier, it's nice to see that you're human and you have messy code or you make mistakes. And that's definitely a part of this process.
Yeah, for sure.
And, we try and make a final product look polished, but there are a lot of steps along the way that are less.
Exactly.
Polished.
And even sometimes we will commit code, to the final product that is still not polished, and we'll go back and do it. It's, we use Git and GitHub and for version control. And it's a really excellent tool for that because it's very easy to go in and say, oh, this should have been better, or that broke something, let's revert it, that sort of thing. Makes it very simple. There's a question in Discord. There's a way to do over-the-air coding on Arduino via Wi-Fi. Is there a utility in CircuitPython? Not that I'm aware of.
So there's something that Scott is working on, but it's not at a state of being ready. The vision is that will go over a Bluetooth connection and be usable from tablets and computers and all those things, but it's not ready yet.
Yeah, it's not out yet, don't ask. So we're working on something like that, but it'll use Bluetooth instead of Wi-Fi.
Well, it's possible someday we would get to both. And, if you have ideas and, we love ideas. We love people who can kind of bring those ideas to fruition more. So it's possible that there's a community member out there who is the one to really kind of bring this into being, because we're also busy with other stuff, and prioritizing everything is hard. So Noah had asked, I remember seeing a Canadian flag on your wall. Was that a hard-coded?
It was hard-coded. And it was nasty looking. It was like pixel by pixel sort of done. I didn't write it. I just got to see it. But yeah, it was definitely hard coded. And we've done like some logos and some other stuff that we've put up there, and all of it's just been like mapped in code.py. And almost all of them we had to disable other animations, or it would cycle through so many of them and then just stop. So I guess we're close to finishing up. Did you have any more questions?
Well, I wanted to hear kind of your hardware picks for somebody who's just getting started, maybe with CircuitPython or maybe with LEDs. Where do you start?
So the best place I think to get started with, if you want to use the LED animation library, but you want to have other options for learning and so on, is the Circuit Playground Bluefruit. I realized I cleaned my desk and I don't have one. So it's a small board, but it's got a lot of sensors and buttons and inputs and GPIO and all this stuff packed into this small form factor, and it includes 10 LEDs around the outside of it.
I've got one if you want to switch my share on. Right. It's not hooked up or anything, but this is what we're talking about.
Yeah, I've also obtained one apparently.
Okay, yeah.
So this little board will run all of the animations, and it gives you a lot of options to do a bunch of stuff. And so it is great because you don't have to solder really to do a bunch of different projects with this board. So it's a great way to get started. The other option is if you want to do a little bit of soldering, the Feather M4 or the NRF 52840, plus the NeoPixel or Dot Star Feather Wings. The library also works with dot stars. So if you are looking to, and that's what these are feathers attached to Feather Wings. I know they're dark, but that was the only way to get the LEDs to show up properly.
Mm-hmm. Yeah, they're always a challenge to get on camera.
Yeah. And so those are the other two things I would suggest. A lot of the demo stuff was written for the NeoPixel Featherwing, although it's easy to update. But if you want to just be able to use all those examples in the guide right off the bat, NeoPixel Featherwing is the way to go. And I also wanted to show this. This is a NeoPixel ring in a 3D printed case for diffusing. And this is ring mode, which will end up being handy on the Circuit Playground Bluefruit if we end up getting it included. But you can do it in any form factor. So if you made the concentric rings on your wall with strips or something like that, you could definitely use the LED animation library for all kinds of fun stuff there as well.
Mm-hmm. And speaking of the diffusing plastic, I want to give a shout out to Noah and Pedro, because they've done a lot of projects that involve 3D printing and integrating these LEDs into them. That reminded me, they did a really awesome looking, I think this used a laser cut or a CNC mill plastic, but on a small ring, and it looks so good. I love seeing their stuff. And I'm sure Anne has been sharing so many links in the Discord, so if you're on YouTube, join us on Discord and get the links from Anne, because there's links to guides and products and all of this stuff.
For sure.
So DV asks, what version of CircuitPython has all this pixel buff awesomeness? I think 5.3 is pretty much complete, so you can go get the stable version. Yeah.
And 6.0 has it as well. So if you are looking to go bleeding edge and try stuff out, you can also do the alpha. I have the alpha on all these boards and have not run into any problems.
Great.
So that's another way to go. So the pixel buff stuff is built in, and NeoPixel and DotStar are designed to use it. So you don't have to actually interact with pixel buff. Pixel buff just exists and interacts with the other libraries. All right. And with that, I think it's time to wrap up. I think you need to
wrap us up.
I do. So this has been a CircuitPython conversation with Jeff and Kattni. Thank you for joining us. We wanted to be able to chat about stuff for CircuitPython Day, and these were the two projects that we thought you would enjoy the most. So we have up next is Scott, who's going to be doing his deep dive live stream that he normally does on Fridays for CircuitPython Day today. And so he's starting at 5 p.m. Eastern and whatever time that is in Pacific. But he's starting in 2 minutes. So we're going to jet. And thank you, everybody, for watching. Thank you, everybody, for participating. I hope we answered all your questions. Check out the links in the chat for more information. And with that, I will say farewell.
It was nice seeing everybody.
Yeah. Thanks again, everybody, for watching. And we will see you again in the chats.
All right.
Later.